Okay, for some reason, I tried recording this and it didn't work the first time, so we'll try again. Quadratic review. This first one, they want you to put it into quadratic or factored form from the quadratic standard form. And so I went straight to the two binomials, knowing that this first spot times this first spot is going to give me the x squared. So x times x gives me x squared. And that these back two, when I multiply them together, gives me 10. And when I add them together, it gives me 7. So x plus 5 times x plus 2 is the factored form of this same equation. Meaning, if I took and distributed the x, then distributed the 5, added like terms, I would get this exact expression. Now, because of that, I can find my, because of these, I can find my x-intercepts, because the x-intercepts and solutions are the same thing. So I can take my factors and set them equal to 0 and solve for x. So that means x would be -5. So -5, 0. And then this one, if I set that equal to 0, x plus 2 equals 0. So I'd subtract 2 from both sides, and that would give me a -2. So it would be -2 and 0. My leading coefficient is the number in front of the x squared. In this case, there is no number, so it's assumed that it is 1. And because it is a positive 1, it will open up. So it looks like this. And then since it's opening up, it's going to have a minimum. Okay, I did the second one with you in class, but we'll do it again. So this is going to be very similar to this. The difference is we have this negative sign in front. So I'm going to take a -1 and put it outside. That means I have, since I took the -1 out, I'd basically divide all of this by -1. That gives me a positive x squared, a -8x, and a positive 15. So when I go to factor it, again, there's a 1 in front of this x, so we don't have to do the AC method, which is nice. So we can put an x here and an x here, and then we just need to find these two that multiply together to give me a positive 15. So 15, the factors would be 15 and 1, or 5 and 3. And if I multiply a -5 and a -3, that gives me a positive 15. But if I add -5 and -3, I get a -8. So those would be our factors that we're going to plug in here. Now, I could put -5 here and -3 here, or vice versa. I could put the -3 here and the -5 here. In this particular situation, it doesn't matter. Okay, so we'll just do -5, -3. And so then when we take the intercepts, we take each one of those and set it equal to 0. So x minus 5 equals 0. And add 5 to both sides, x will be 5. And then x minus 3 equals 0. Add 3 to both sides, x would equal 3. So the two x-intercepts are going to be 5, 0 and 3, 0. And then our leading coefficient here is also 1, but it's got a negative in front of it, so it's going to be -1. And because it's a negative, it's going to open down. So it opens down, and if it opens down, it has a maximum. All right, number 3. This one is already in factored form, and they want you to put it in standard form, which is the way this is written right here. So standard form, if you remember, is ax squared plus bx plus c, meaning there's an x squared, then there's an x, and then there's a letter without an x. So in order to get that, we're going to FOIL, first, outer, inner, last, or another way I like to call it is double distributing. So we take x times x, and that gives us x squared. And then we take x times -4, that's a -4x. 5 times x is 5x. And then 5 times -4 is a -20. And at this point, these two numbers should be like terms, and we can combine those for our final answer. So x squared, -4 plus 5 is a positive 1, x, and then minus 20. Now, x-intercepts, we're going to just use these guys, right? And we set those equal to 0. So x plus 5 equals 0. Subtract 5 from both sides, it's -5. Oops, 5. And then x plus, what's the other one? Minus 4, Tammy. Sorry. X minus 4 equals 0. So I add 4 to both sides, and that would give me x equals 4. So then my x-intercepts are going to be negative 5, 0, and 4, 0. And the leading coefficient here, we look at our standard form, and there's a 1. Now, so happens that all three of them that we've done so far have all been 1s. That's not always the case, but a lot of times it is, but not always. Now, again, our leading coefficient's a positive 1, which means it's going to open up because it's positive. And then since it opens up, we will have a minimum. On number 4, we're going to distribute. Now, you can do this a couple of ways. You could distribute, double distribute, FOIL, whatever you want to call it, all this, right? And then apply the negative to everything. Or you can distribute this negative to the first thing, right? And then take negative x minus 4 and distribute it. Okay, my personal preference would be to go ahead and do the double distribution and then apply the negative to everything. So that's what we're going to do. So x times x gives us x squared. X times negative 3 is a negative 3x. 4 times x is 4x. Not sure if you guys can see that. There we go. And then negative 4, or negative 3 and 4 is a negative 12. But again, we have this negative in front of it, right? So that's going to change the sign of every single thing here. So that's going to make, we'll go ahead and change that to a positive, and this will make this negative, this positive, this negative, and this positive. So we have 3x and negative 4x, forgot my x. Negative 4x would give you a negative x. So negative x squared minus x, and then plus 12. Okay. X-intercepts, we go back and look at these again. So x minus 4 plus 4 equals 0. That's going to subtract 4 from both sides. It would be x equals negative 4. And then x minus 3 equals 0. You add 3 to both sides, so x would be 3. So your intercepts then are going to be negative 4, 0, and 3, 0. Our leading coefficient here is a negative 1. If it's negative, it opens down, and that would produce a maximum value then. All right, down here at the bottom, they want us to sketch a parabola based on the criteria they give us. So this one has 2 positive x-intercepts. That means that it's going to cross x on this side of the y-axis, right? Because these numbers over here are positive, those numbers over there for x are negative. So both the x-intercepts are positive, and it has a positive leading coefficient, which means the a value is positive, which would mean it's going to open up. So we've got a parabola that opens up, and it crosses on the right side of the y-axis. It can be tall and skinny. It can be kind of wide like that. It's whatever your little heart contents. It doesn't matter. I'm just going to go just like that. Okay. Again, it could be shifted a little bit to the left. It could go to the right a little bit. It could go down some. Whatever, as long as it crosses the x-axis twice on this side of the y, and it opens up. That's all they wanted. On number 6, it has a positive y-intercept, meaning it's going to cross y anywhere up here, right? Not down here. So I'm just going to pick a spot. We're just going to say it crosses there. And it has a minimum of negative 2. If it has a minimum, that means it's going to open up also, because it'll have a spot that it goes down and then turns back up. So I can just take this and draw a parabola so that it crosses at negative 2. 1, negative 1, negative 2, bam, right there. Okay? And number 7, it says it has a positive and negative x-intercept. So one side's going to be over here, one side's going to be over here, and has a maximum of 3. So 3 is going to be right there, right? Now it doesn't have to cross the y. I mean, the maximum doesn't have to be on the y-axis. It can be, but it can be off to the side a little bit too, as long as you have one of your x-intercepts here, positive, one's negative, and the maximum is 3. Oops, sorry. All right, number 8. On here they have given us a quadratic equation, and they want us to graph it and find all this information out about it. And really, it's easier if you find all the information first and then use that information to graph it. So, the axis of symmetry. If you recall, the axis of symmetry is found by taking negative b and dividing it by 2a. Remember, your a is the number in front of x squared, your b is the number in front of x, and your c is the one without the x. So, negative b, or the opposite of b in this case, is going to be minus 2, and it's going to be divided by 2 times the number in front of x squared is 1. So negative 2 divided by 2 is a negative 1. So your axis of symmetry is at negative 1, so it's written x equals negative 1. So a lot of times I will go ahead and just draw a real light little squiggly line. So I know that my parabola, that's the middle of it, right? So half of it's over here and half of it's over here, and somewhere on this line is my vertex. Whether it's a minimum or a maximum, we can tell by this number right here. It's positive, so it's going to open up. So we're going to have a minimum vertex somewhere. All right. Also, this negative 1 becomes the x value of our vertex. Okay, so you can just put it right there. And then our y value we get by taking this and plugging it into our equation. Because, remember, this guy is the same as y, right? It's basically, it's our y value, our y equals this, okay? Meaning, this guy is going to change based on what we put in for x. So, I'm going to put negative 1 in for x. So what that's saying is that with this relationship, if I pick negative 1 to put into x, I'm going to get out over here the place on this line that it lives. Okay, so I put negative 1 here and square it, plus 2 times negative 1, and then minus 8. So that's negative 1 times negative 1 is a positive 1. 2 times negative 1 is a negative 2, and then minus 8. So that is negative 10 plus 1 is a negative 9. Okay. So our vertex is negative 1, negative 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, way down here. Okay, we'll just go right there. And we know also this number, this number back here without the variable is also our y-intercept. So where it crosses here. And it crosses at negative 8, so it's going to cross right there. And because this is the axis of symmetry, right, I know that there's going to be another point just opposite this one across the axis of symmetry on the other side. Now, we also need to find out what the x-intercepts are. Our y-intercept we said was negative 8, so that means we're going to have 0, negative 8. All right, and our x-intercepts we get by factoring, okay? So let's see if we can factor this here. All right, we have x squared plus 2x minus 8. Again, since this is 1, we can just go straight to this. All right, and we put x here and an x here. And then we need the factors of negative 8 that when you add them together give you positive 2. So we have 8 and 1 and 4 and 2. But it's a negative 8, so one of these has to be positive and one of them has to be negative in order, because when you multiply, a positive and a negative give you a negative. So our answer, though, when we add them has to be positive. So that means our 4 has to be positive and our 2 must be negative, because 4 times negative 2 gives you a negative 8, and 4 plus negative 2 gives you a positive 2. And again, I could put the negative 2 here or I could put the 4 here. It does not matter. Okay, so plus 4 and minus 2. Now we set that equal to 0, and then we take each one of these and set it equal to 0. So I subtract 4 and get negative 4, and then x minus 2 equals 0. I add 2 to both sides, so x is 2. Those are our x-intercepts. So our x-intercepts are going to be negative 4, 0, and 2, 0. The domain of parabolas, unless they tell you otherwise that the domain is limited, is going to be all real numbers. Okay? And your range, all you have to do is say y, and then you put your y value of your vertex. In this case, it is -9. Okay? And it opens, we said it opens up because it was a positive. That means that -9 at -1, -1, -9 is a minimum, meaning everything's above it. So all the y values are going to be greater than or equal to -9. All right, number 9. Again, the axis of symmetry. Remember, this is A, this is B, and this is C. Axis of symmetry is -b over 2a. So in this case, we'd have a -2 over 2 times +1. So our axis of symmetry, again, is -1. Okay? And then to find the vertex, we know the first part is -1, right? That part just comes right there. Then we take -1 and we put it back in this equation to find out what our y value is. So -1 squared plus 2 times -1 minus 3. That gives us -1 squared is 1. 2 times -1 is a -2, and minus 3. So there's a -5, plus 1 is a -4. X-intercepts, we have to take this little guy. We're going to take him, and we're going to bring it to the side over here, and we're going to factor it. So x squared plus 2x minus 3. So we have x and x, and then the factors of 3 are easy. It's just 3 and 1. But one has to be positive and one has to be negative, right? But when we add them, they have to be positive. So the bigger number has to be positive, which would be your 3. And then your 1 is negative. Okay, set those equal to 0. And x plus 3 equals 0. And x minus 1 equals 0. Add 3 to both sides, or excuse me, subtract 3 from both sides. You get -3. And we add 1 to both sides, and we get a +1. So our intercepts are going to be -3, 0, and 1, 0. And we find the y-intercept again by looking at this back number with no variable. And it's a -3. So our y-intercept is at -3, 1, 2, 3, right there, which is 0, -3. Okay. And we know now that it crosses, oh, I forgot to graph that last one. We'll go back in a minute. Our x-intercepts are -3. And our y-intercept are in 1, 0, sorry. And then we know our axis of symmetry and vertex are going to be at -1, -4. We got all kinds of dots there. So now we just literally play connect the dots. And draw your parabola. Okay. And we'll come back up here to this one. We forgot to graph. Again, our vertex is -1. Oh, we got these points. That's right. We got these points on here. Now we need to put our x-intercept. So -4, 1, 2, 3, 4. And +2. 1, 2, right there. And then again, we just play connect dots. Just like that. Okay. Coming back down here. Oh, we didn't answer. Man, I'm all over the place tonight. Sorry, guys. Domain, again, is all real numbers. And your range, there's your y. Your y value of your vertex is -4. And it's opening up, so everything's going to be above -4. So it's greater than or equal to -4. Okay? Simplifying here. Remember that I equals the square root of -1. So if I have a radical with a negative in it, I need to separate it to the square root of -1 times the square root of 49. And I know that the square root of -1 is I, and the square root of 49 is 7, and it's just +7 if we're just simplifying, which we are. If we're solving for a variable and we have to take the square root of something, then it's going to be plus or minus. But so in this case, when I multiply these together, we get 7i. Woo, Tammy, there we go. 7i is your answer.